Alright, so like I said, today we're going to be talking about the Pythagorean Theorem. Pythagorean Theorem.
It says an
You don't need to remind me of Mr. Thomas.
No, don't want to hear
IT. The very big little house? Yeah, me too.
What did you say?
it. Alright, so, as Alexis already told us, we know that according to the Pythagorean Theorem, a squared plus b squared is equal to
No credit for that.
c squared.
He's an Isaac.
And so again, what we're basically talking about here is A and B are the two legs of your right triangle. Again, there is a catch to the Pythagorean Theorem. It only works with right triangles. Okay, so let's make a special note of that.
Only works for right triangle?
Right triangle. So we have A and B as our two legs of the right triangle, and C is always the hypotenuse. So we have A squared plus B squared equals C squared. And this is something I know that a lot of you guys have seen before. You probably have done this a lot. It is one of those things where geometry actually does get used in the real world. You do need this. I think you'll be surprised how it actually applies in a lot of the different fields. That's very interesting. Go ahead, Mackenzie.
Is C the hypotenuse?
C is always the hypotenuse. Now, a couple of things where we go from here is we also have these things called Pythagorean triples. Pythagorean triples. A Pythagorean triple is basically three whole numbers that create or that satisfy the Pythagorean theorem. And one of the big ones that you guys are going to see a lot in high school is a 3, 4, 5. And this is definitely one of the big ones that you'll see a lot. You will also see a 5, 12, 13. Now, for those of you guys who are interested in construction, a 5, 12, 13 should start ringing a bell, because that's what most pitches of a roof are based on. Where you have the, I can't think of it right now, but basically you have it where it's 5 feet tall and 12 feet long, and therefore you have the slanted length of your roof, which is generally about 13 feet. And that's pretty standard for a lot of the trusses and homes. So 5, 12, 13. Now what's really important out of this is if you guys start to be confident, start putting time into it, where you want to be able to recognize Pythagorean triples very quickly, and it does save you a lot of time, all the families of these triples make it really easy. So a family of the triple would be one where it's like multiple. So let's say I have a triangle that has sides 6, 8, and it's a right triangle. What does that make my hypotenuse? 10. Everything's just double. So if I have a 9 and a 15, what does that make the other leg?
12.
12. Again, everything's being multiplied by 3. So then you have these infinite families that you can basically multiply by any value. That's how you get your family. So what would be an example of a family for 5, 12, 13?
10, 24, 26.
Okay, what else?
20, 48, and 30. 52.
Yeah, 52, right? For those guys who like cards.
Sarah, you are really smart.
Yeah,
Okay.
no, not at all. That's the
Let me give me one more for 5, 12, 13. Multiply by you. Brian? 40. Okay.
86.
96.
96. Well, 104.
And 104 is correct.
You're just
Alright.
like throwing that
So those are Pythagorean triples. Now, one of the things you guys might not be aware of, this is kind of interesting. We said that it's equal if and only if it's one type of triangle.
Right.
Right triangle. Okay. So one is that's kind of neat is you can actually determine if a triangle is acute, obtuse, or right based on nothing but their sides. We don't know anything about their angles.
There we go.
So we already said if it's a right triangle, what is true? What's true about my sides in a right triangle?
Ooh, no, never mind.
By the way, we've been talking about this today. What's true? What's the formula?
A squared plus B squared.
There we go. So a squared plus b squared equals c squared. Okay, now for an acute and obtuse, it's the same thing. A squared plus b squared. And then a squared plus b squared equals ac squared. But there's something weird about this. With an acute triangle, if it's acute, a squared plus b squared is greater than c squared. And if it's obtuse, a squared plus b squared is less than c squared. Okay? So, what we're going to do is practice. So our first task is to practice whether or not the three lengths are a right triangle. If they're not right triangles, what type of triangles are they? Okay, that's what I'm going to add in there for this. It doesn't actually tell you that in the instructions.
No. It was just one.
Okay, so quickly, using your calculators, I want you guys to do number 3. We've already said number 1 and 2. 3, 4, 5 is a right triangle, right? That's one of the common Pythagorean triples. And a 5, 12, 13 is another example of a Pythagorean triple. So we've already done 1 and 2. I want you guys to look at number 3. I'm going to send you a quick poll. And I want you guys to tell me what type of triangle number 3 is. So very quickly do that. In this next section, what we're going to do is we're going to start off with our right triangles. We'll do a couple examples here. Here's my right triangle. I have 11 and 12, and then x is my hypotenuse. How would I start solving for x?
A squared plus B squared equals X squared.
So a squared plus b squared is equal to x squared. Okay, very good. So which one's a and which one's b?
A is going to be 12
Okay,
and B is going to be 11.
so b is 11. Does it really matter which one's a and which one's b?
No.
No, doesn't matter at all. Okay, so what's 12 squared?
144.
Okay, what does that give us? 165. And so how do I solve for x? Square root of 265. For your homework tonight, unless otherwise noted. I want you guys to leave this in radical form.
Just leave it like that?
Well, it depends. Can we break down the radical?
Not to a whole number, right?
Well, not necessarily the whole number. Like, can we break down? Remember we had to break down the radical before? Yep. Is there a perfect square that divides evenly into 265?
Well, there might be, but.
All right, Bree, let's try. Because right now, it doesn't really seem like there might be one. So, Bree, you said 5, right? 5 times what?
53.
5 times 53. So that's the square root of 5 times 53. All right, here's a slight problem. What do we know about 5?
I don't recognize anything else here. It's just 3. So,
It's a prime number.
yeah.
Okay, that presents a big problem. What about 53? What do we also know about 53? It's also a prime number. And neither one of those are perfect squares, therefore, that is right here. That's as far as we can go. So leave it as the square root of 265. All right, this time let's try something a little different. So now how do I set up my problem?
You can do like a squared plus x squared equals 5.
Okay. So therefore 6 squared plus x squared is equal to 12 squared. All right, so what is 6 squared? 12 squared? Okay. Which is, okay, so therefore x is equal to square root of 108. Can that be broken down? With what, Bree? 4? Oh, we could start with 4, Kirsten, but we might be able to go larger than 4. That? No. Okay, let's try 9. I think we might be able to go bigger than 9, but 9's a great start. So 9 times what? 12. So that gives us the square root of 9 times the square root of 12. What's the square root of 9?
3.
So now I've got 3 radical 12. Is that complete? Why not?
Because 12 can break down to 3 times 4.
Yeah, so I can break down 12 even farther. So now I got 3 times radical 4 times radical 3. What's radical 4?
2.
2, so that's 3 times 2 times root 3, which then gives me 6 radical 3. And that would be your final answer. Okay, how are we doing on this?
Awesome.
Got it? Sweet. All right, so here's what we're going to do. I want you guys to still practice. We're done their notes, but we're going to practice some more in class.